Today's lesson is on congruent segments and midpoints and how to recognize what congruent figures look like in the world of geometry. So this is section 1.5. We'll start with the definition of what a midpoint is. A midpoint is a point that divides a segment, notice not a line because you can't divide a line, but divide a segment into two congruent segments. Okay? So a midpoint would be the point that is right in the very middle of the segment. Congruent segments would be segments that have the same length. By finding the midpoint, you create congruent segments. We use something called tick marks, which would be like a little scratch mark here. We call those tick marks. Tick marks show that this segment would be the same length as this segment. Okay, that's a tick mark. Another way to describe congruent is to actually use the symbol for congruent. The symbol for congruent is an equal sign with the little squiggle over the top. It looks like the Spanish tilde if you are in Spanish class. We would say, for example, if this is segment A, and segment B, and segment C. Those are in bad places, but you understand what I'm trying to show you. We would say then that segment AB is congruent to, and then to BC. Oops, I need to put enough space in there. And then we would actually use the equal sign with the little squiggle over the top. Okay, so that's how we would use that. We would say that, and then we would put the line symbol over the top of our segments to show that they are in fact segments. Okay, so that's how we would use the congruent symbol. If you're going to talk about length, for example, if I would say that AB is 7 units long here, okay, so if I say that that's 7 units long there, then notice I don't put the segment symbol over the top, okay? If I put the segment symbol over the top, I'm talking about the figure itself. But if I don't put the segment symbol over the top, then I'm actually talking about the length. I'm talking about how long the segment is. So notice AB doesn't have an equal sign over the top, or doesn't have the symbol over the top of it because it's using the equal sign to say that it's equal to 7 units. It's important to know when to use the equal sign and when to use the congruent symbol. Okay, so these 4 examples give us some ideas. Notice that in the first example here it says MN, so that's the length from point M to point N, and we're going to say that that's 12 units long. Since we're talking about the length, we're talking about a numerical value. Numerical value would tell us to use the equal sign. Okay, we only use the congruent symbol when we're talking about the figures themselves. Otherwise, we use equal signs if we're talking about a numerical value. In example 2, we're saying segment PQ and segment MN. So since we're talking about the segments themselves, we would use the congruent symbol to describe those. Example 3, a small case M in front of a segment or in front of an angle or in front of anything means the measure. So we're saying the measure of segment CD. It means the same as this. Say writing it this way or writing it this way would mean exactly the same thing. The measure of CD, since that's a length, that would be an equal sign that we would use there. And in example 4, notice that there's no segment symbols over the top, so they're saying the length from Y to Z and the length from F to G. So again, we would use the equal sign for those. So that's how you know whether to use equals or congruents. All right, the main topic of what we're going to look at today is something called the segment addition postulate. A postulate is a general rule that we use. Everybody just accepts it to be true. what this one says, segment addition says, if you have 3 points on a segment, okay, so A, B, and C, it says that if you add one smaller segment, in this case AB, to the other smaller segment, in this case BC, that's got to be equal to the total segment, which is AC. So you'll hear me say, the distance from A to B plus the distance from B to C has to equal the distance from A to C. Okay? Now, numerically, that makes sense. If AB was 10 and BC was 4, we would say that AC is 14. We would add 10 and 4. In the world of algebra, sometimes, though, you don't always just get to add things. Okay? In this case, in example 1 here, we see that the distance from N to O we know is 25, but we do not know what OP is. We do know what that NP, the total, is 41. So we're going to use this idea of segment addition postulate and set up an equation to solve for X. So what we would set up is 25 plus X equals 41. And then we would use our algebra skills. So we would subtract the 25 over to the other side, and 41 minus 25 is 16. So our X value would equal 16. The distance from O to P would be 16. In example 2, notice I have X in 2 different places. It doesn't matter. X could be in 14 different places. You still set up the problems the same way. Take the smaller segment plus the other smaller segment and equal it to the total. So in this case, I would say X plus 3X plus 1 equals, in this case, 25. And then I would do my algebra magic here. So I would add my 1X and 3X together and get 4X plus 1 to get 25. Then I would subtract my 1 over to the other side to get 24. And then I would divide by 4 to get 6. So my X value would be 6. I can always plug it back in and make sure that that makes sense. Okay, so for example, I can see that the distance from A to B would be 6. And then the distance from B to C, I'd have to plug the 6 in. So 3 times 6 is 18 plus 1 is 19. So 19 plus 6 is indeed 25. So I did that correctly. The last kind of problem you're going to see today is a combination of segment addition and the idea of what a midpoint does. Okay? If you know that your point is in the middle, okay, notice back here, we did not say that O was the midpoint. We just said that it was in between, okay? So we didn't know it was the midpoint. But in this one specifically, I say it is the midpoint. So going back to midpoint, that means that we know that RM and MT have to be exactly the same length. Those are congruent segments. So we're going to set up our problem a little bit differently now because we also don't have a total. It doesn't say RT equals anything. All we know is that RM has to be equal to MT, and we know that because we were told it was the midpoint. So we're actually going to set this one up a little bit differently. We're going to set up 5x plus 9 equal to 8x minus 36. And then from here, we're going to do our algebra. So we would subtract the 5x over here, so it would go down to 3x. And then we would add our 36 over to this side and get 45. And then we would divide by 3 to get that x is 15. Okay. Notice, though, in the problem it says find the length from R to M, the length from M to T, and the length from R to T. So we would take our 15 and plug it back in. So for R to M, we would do 5 times 15, which is 75, plus 9 would give us 84. 8x, so 8 times 15 would be 120, minus 36, again, would be 84. And then R to T would just be the combination of those two. 84 plus 84 would be 168. That is the end of the lesson.